Hello everyone, welcome. Today I just want to recall that the first day we introduced the Jupyter Notebook tricks, magics and all those things, and then next day I introduced lists. Today I'm going to introduce lists where functions are evaluated inside the list, okay, which is called list comprehensions. So that's what we are going to do. So we saw all these things, but if you recall, I made a very slyly introducing an advanced concept called list comprehension without saying too much on that. And here I'm recalling that here. So we know that list is bracketed with the square brackets, and whatever inside that separated by comma are the elements of the list or members of the list. And what we are saying is you can create a list with actually a computed quantities inside. Here what I'm saying is compute I square, for what the I is the input value. What is I? Where is it coming from? It is coming from the range between 1 and 100,000. Of course 100,000 is not included. It starts with 1, okay, and increments by 1 unit, 1 2 3 4 like that up to 99,999. And this will give you all the list members in this one. So you are going to have 99,999 elements inside. Each of them are separated by comma, and the boundaries are separate. Boundaries are delineated by the left square bracket and right square bracket. But lists don't have to come like that, okay? Only through a computed quantity. And that's where I was talking to you that look, I can actually create a list here. For example, I typed this list here, okay? I could have typed like this, positive int squared, but only for the first, whatever I created here for 10 observations, 1 to 10. The range is 1 to 10. I basically create that way, or I could have actually typed it, okay? So you can, create lists also individually typing and creating it yourself, or in the process of doing your programming. And it doesn't have to be only numbers. It can be strings also. We talked about it. Strings, these are all called strings basically, and these are about various different berry types, acai berry, gooseberry, blueberry, like that. And then I also have names here just for fun of it. And then we kind of said you can actually identify because each of these members are identifiable by their index position. You can actually get the 7th element from the positive int squared 7th element in this way. Just put the index, and then it will give you that turns out to be 64. Okay. Remember, the index index starts with 0. Okay. That's why it is 0 1 2 0 1 2 3 4 5 6 7 8. No. 1 2 3 4 5 6 7 8 9. Okay. So I explicitly asked for 1. For the computational purposes, I said range is 1 to 10, and then it takes only from 1 to 9, and it computes this. But what is its index position? This is 0. This is 1. This is 2. This is 3, and so on. Okay. So if you do that way, that's why 7. Even though it says 7, we are talking about here is the 8th position, because it starts with 0. Okay, and P0 is 1. We can also do if you want to output the index position given a value, then use the index method. Okay, so we are now start talking about methods. There are different methods we have. We'll come to that, and and you can also slice the list. That's what we gave these examples in the last class. Something I want to tell you is that there are lots of different functions, methods. I missed yesterday 2 things. One is the extend method. For a list you can extend it. We'll see an example in the next for going forward. For now, when I am talking to you about the tuples, okay, today or tomorrow I will introduce tuples, and just to tell you what they are comparison to list. It is it has functions of list, but anything that changes the tuple, it will not work. That's what it is. So in other words, tuples are not mutable. Tuples are immutable, and lists are mutable. That means you can add eliminate, drop, insert, pop, remove, all those things you can do for list, but you can't do, you cannot do extend, you cannot do insert, you cannot do pop, you cannot do remove in the case of the tuples. And they are written in, the tuples are contained with the regular parentheses, while square parentheses are given for lists. Okay, we'll come to that later. So I didn't teach you that extend version of it. We are going to use an interesting situation why we need, extend will be very helpful. And then, I also did not, I think one of them only extend and the copy. I didn't teach you about copy. Again, I want to give a quick review of copy. You can make a copy just use the method copy for a list you have. Then you get a new copy of the list. But this is called a shallow copy. That means it doesn't really copy all its properties. If it is exactly same, it should be referring even to the ID of that copy should be exactly same. But if it is not exactly the same, then it's called shallow copy. Okay, not all the properties and are not exactly same. It's called shallow copy. So there is a deep copy and shallow copy. And you can see that in this example, I'm speaking with you and giving you an example here. I talked to you quite a bit of this copy related details here, and you will see that when I do the actually maybe it's down here. Okay, not here. Maybe just a moment. I'll check it out where it is. So here is something there. I talk about it here. So I take just a copy of it, for example, names and copy. Okay, it takes a copy of all the names here in names 1. And if you print names and names 1, they will be same. But if you look for the ID of the names, the object ID of the names 1 as well as names, they will be different. Actually, somewhere in this worksheet I have shown that example that it is indeed different. So here it is. So if you go down in this example, I think somewhere here I'm printing, I'll show you that here it is. You see this one, print ID of positive int squared and the print ID of positive int squared copy. Okay, and positive int squared copy is the one which is just coming from copy method. Okay, positive int squared copy is just applying the copy method. I don't want to call this as a function. Some people say that, you remember, anything anything attached to an object as a method, a specific function object attached to an object, I will call that as a method. Okay, otherwise it's a function. Okay, because both of them have the same type of parentheses, so I want to differentiate them. So, and the big difference is also that you are going to, if it's a method attached to an object, you call you apply it with a dot. But if it is a function, a programming function available under Python in general, then you use it on the left side here, copy. You'll have to do like that. Okay, so that's a big difference between a method versus a function. I think there's a lot of confusions going on there. These are the things that bothers me anyway. So remember that it's very easy to know that if it is a method associated to an object, then it has to be on the right side, dot with a call of a dot, that method expression, method word, keyword, and then of course you will have because it has function type function type behavior, you will have the same type of parentheses for both generic functions, Python functions, and also for methods of objects, which is also a type of function. Okay, but I don't want to call them as functions. I will always call them as methods. And then so I have mentioned here, and you will see that when I make a copy, okay, I make this copy through the copy function, which is a shallow copy. So this is a shallow copy. Okay, and because it's a shallow copy, if I compare these things, I will ask, is this same? That's what this function means. Is positive int squared is positive int squared copy, and you will see actually false. Okay, the answer is false. You will see that in the top. It is coming here in the top because I copy that and print it. Everything same, looks same, right? They are false because their IDs are different. Okay, so IDs are printed at the bottom here. I should move that, because it's a different section. This is about the directory of an object. Okay, so we'll come to that. So again, I am making some sly comments here, like objects. I said about what does that mean? You know, I didn't tell you a lot of details, but you know, we will go around many times, and also eventually when we talk about the objects, you know, you'll be really good because you know how to connect to them, how to apply them, and then we introduce, you know, what is meant by object later on. You know, it will work better, I feel. You know, otherwise I will change the order of the presentation for future. Okay, so I also want to introduce one more thing, that is the about directory. Okay, so given an object, you can, you know, look for what is the directory of the object, because an object contains methods as well as, you know, various other attributes which are fundamental to that object to work well for us. Okay, for example, when, you know, because we know that it's a list, positive int squared, it's a list. So let's just, if you call for directory of positive int square, and I also make a, you know, directory of positive int squared copy also, to show that everything is same except for the ID. You know, that's why we know that, you know, one is a shallow copy, the other one is deep copy, and when I do the deep copy, the even the ID will be same. Okay, so I do the, you know, directory here. So here is the list of elements of that object. This is generic to the list because it's a type is list. This is giving you, these are all the things associated, these are the attributes which helps us do many things with that particular type of object, in this case list, and you know, and it gives you all those things for us. And I printed here for both, you know, positive int squared and positive int squared copy, and you will see exactly same, everything is same. Okay, and that's where I am saying, okay, number is same, you know, items are same, but then they are if I check whether is copy int squared, positive int squared versus positive int squared copy, they are not same because it's false, and the reason is the IDs are different. Okay, because I just check for the IDs here, you can see I asked for type and it is, you know, list, it will say list. Where is my stuff here? So here, you know, print ID positive int squared, print ID positive int squared copy. So once you start a system, you know, Jupyter Notebook, when the whole instantiation of the platform is done for you, and whatever we do, you know, every object has its place, name, ID, and so on. Okay, so the IDs are different when we do a shallow copy. So that's about something about, you know, we will refer this shallow copy, deep copy, and so on later on in the future if need be. So we did all those things. Okay, I want to stop here because it's a kind of review, yesterday review as part 1, and then let's do the you know, other things are all same, right? List slicing and so on, it is same. We talked about all those details, and not much differences there. But you know, comprehensions, you know, list comprehensions is where I am going. I have a lot of other notes, you know, we don't need to go over those notes, but let's go on the essential, talk about the essential things. So here is the comprehended list. Okay, I want to call it as a comprehended list rather than, no, it's much easier to call, oh, this is a comprehension based list creation. So here is just a linear function for the input x, for x is ranging in this 1, 20, and 3. And this is what I was saying, that, you know, the range can be not just sequentially incremented 1 unit, but also incremented by 3 units. Okay, and so it says start with 1 and then skip 3, and then you are going to when you skip 3, you are going to 4, right? And then if you do 4 by 3, 4 times 3 is 12, 4 times 3 is 12, right? Let's see, you know, I think I should do the print range also. I hope it, one moment. All right, let me come back to this one again. Comprehended list, this is just a linear function. I'm saying another computable quantity, but you know, what is the input? Input is coming from this range. Okay, there are more complex, you know, input range, input sets I can create. Also more complex functions I can create. You're going to see that momentarily. So I just want to tell you that, you know, when I just do the, you know, what is this range values are? No, I have to convert it to C. You know, so this is what I converted. I converted it as a list. Okay, it's a list is a function, Python level function, not a, I'm not talking about the list object right here, right? Of course, it will create the object, list object. So when I do that, it says, you know, these are the values, because it is start with 1 and then jump every 3 units. So 4, 7, 10, 13, 16, 19, up to a maximum of 20, right? and then I am using that as input for me to calculate these values. But remember, when I calculate the input for this, I put, first value is, this one, 1. When I do that 1, it is 5, right? X is 1, so 3 times 1 is 1, 3 plus 2, 5. When I do the 4, 12 plus 2, 14. And then when I do 7, it is 21 plus 2, 23, and so on, okay? So this is the, this is what is called the comprehension, list comprehension. So you have a function to be evaluated, and then you have to give a range for what value the values are coming from, not range, values are coming from some set, and this, it turns out to be a range set here, a set of values that is defined by range. Now, let's do a little bit more complication, okay? Can I use more complicated if-else type comprehension? Of course you can do. Look at this one. I'm just calculating NP. Now I'm introducing slightly a package numpy. Numpy is, let me write it down here. I should probably have it before, but nonetheless, let's say import numpy as NP. Now NP has certain, not only functions but also certain constants like pi, epsilon, natural, exponential value e, natural log and the exponential value e, and a few other constants are there. So I'm going to use pi because it's such an important value. I can pick it up by, again, pi is an object value coming from the NP package. And then I'm saying r square, n pi, this is n, it's pi r square, right? Pi r square, which is basically the area of a circle. So I'm saying whenever the range of values, for example, else this one, if r is less than 1, if else, r is, for values greater than 1 or other than that, which is basically greater than or equal to 1, use this function to calculate. So for what values of r? For these values of r, 0.1, 0.6, 1, 2, 5. Those are the 5 values. Out of the 2 of them are less than 1. So for them, we are going to calculate, area. Otherwise, I'm going to calculate a circumference. Basically, that's what it is, 2 pi r. Okay. So just as a calculation example. So I conditionally comprehended list. I say this is conditional because if else kind of split is happening. It's a different name. It's very explicit. So I run this one, and I get the answer like this. So the first 2 values are really about area of the circle for r values 0.1 and 0.6. But then it jumps to 2 pi r, which is the circumference of the circle basically, when for the other values, in this case 1, 2, 5. Okay. Verification, I basically verified it by calculating actual values myself and then printed it, and you can see those 2 are same. Now I can also do, I did it again. I don't need to do this for some reason. I can delete it, okay? And then I can actually use multiple loops within the list comprehension. So that's what it is here, okay? So I have list 1, list 2. I'm saying product of the corresponding index position, okay? That's what I'm saying. X times y, okay, for it's something else, a little deeper than that. So I have x times y. So some function writing it as x times y for x in list 1 and for y in list 2. That means I take the x value here, and then for all the values in y are repeated. That's why you see, for example, x is equal to -6 and y is 3. Then you get 18, right? For x is -6 and then y is equal to 4, that's why you get -4. So the faster loop here is the second one. The slower loop is the first one. But nonetheless, it's a double loop calculation that I have done it inside. Is it all possible? No, you can do more than that. Look at this one actually. Is it possible to do more than 3 conditions in comprehended calculations? Of course you can do. So basically I'm saying division by 4 if I is equal to %4 equal to 0. That means a number is divisible by 4. That's what this condition means. Else divisible by 6 if this condition is happening. Else divisible 7 if this condition is happening. Else you say other numbers and other numbers. What are the input values? The input value should be coming from for I, and that I is ranging from 1 to 30. So you can do all kinds of things. It's getting more interesting. The range values, I don't have to say all the time range, right? I'm doing that. It can be coming from a set, okay? And we'll come to that. It can be coming from a list in general. I'm saying list, not set, list, okay? It can be that list doesn't have to be defined like this. It could be any list, computer list, okay, intermediately computer list, and that's what I'm going to show as an example here. So I did this by defining a function. Again, I moved on, jumped on to a new concept called how to define a function. Bam, man. You might wonder, I'm bringing a lot of things, looks like, dumping here, but for me, the logic is what matters, and then introduce the different terminologies as we go along. So, I hope you don't mind this way. I don't mind it. I keep, I keep incrementally adding new terminologies to our discussion. So here I'm defining a function here, division by number I, because I remember, really we want to go how to become productive in, data science. And I started this for really to do more about pandas, but then without introducing you some concepts in Python, I can't win on the pandas side. So I'm hoping, by introducing these concepts quickly, we can do wonderful things in pandas. That's our goal, okay? Because eventually you will be using a lot of pandas. I won't say you won't be using Python. You'll be, hopefully you will use less of direct Python functions, okay? Because pandas is optimized for data science works. Okay. So here the same thing, right? I'm saying define a function divisible by number, some number, and then the range is, I values are given as input. Whenever the given an input value, then you can say if it is the remainder is 0, I%4 means, divide the number I by 4, and whatever the remainder comes, that is called this I%4 means, and it is 0, then it is divisible by 4. And same way 4, 6, 7, and otherwise return this one. So that's what it is, right? Every time you are returning it. If this is one, return this. If this is one, return this, and so on, okay? And now I have defined a function. I'm calling in that function and making it, the list comprehensions much simpler here. Whatever I was doing there, I made it very, very simple here. I bring in a function defined specifically by us, and then for the input for that is coming from, in this case, it so happens it's coming in a range. I'm going to change this also, pretty soon. So that's what the results are. This is same as this output. You can compare that. You can see, and then wait. Can I have multiple functions in a list? Of course, you can do that too. Okay. So here is an example. But now I am going to make a jump here. I'm going to introduce what is called the Lambda functions. Lambda functions are temporary functions. Okay. So here I ended up defining permanently a function, right? This one define a function. That's what DEF means. But sometimes we don't need to define a function permanently because it is going to stay in the memory and so on. And you might do so much of work and so much of changing works. You may want to define temporary functions. So here is an example. Okay, that is called Lambda functions. So I have a list that's going to be my input, and I have a mapped Lambda list. Okay, that means Lambda is a function that is going to work on this list. And then I am mapping that, Lambda is a function that is going to be evaluated on the list, on this list. So I am mapping the Lambda function that I am going to define with this list. Mapping this Lambda function. And what is the Lambda function? Here it is. Lambda, okay, list1 member, list2 member, and that's what I am calling it as a list1 member. It's just the output that we want. What it does is, it takes the function, it defines the function list1 member as list1 member square, and that these are the values from the list1 member, and list1 is given as the list to be operated on. So list1 is your input. Let me say it one more time. List1 is your input. That's what this one is. That these input values are worked out using a function. What is the function? This one, list1 member stars 2, okay, and that I call it as list1 member function. Okay, in other words, this is the function. Really what we have is this is the function. Okay, this is the function, and that is operated on by the list1. Okay, so if you run this one, it says that basically because I squared them, right? So it says the output of this. So I'm making that final. I'm mapping this for. Let me go slowly. This is the function I defined. okay, and that function needs to be operating on something, right? That is the list with which it is operating on. In other words, that's the input for me. The input is coming from here. I calculate that using this one, okay, and then and this kind of representation is called lambda function, okay. And I am mapping this. The computations are actually happening only because I use the function map. It's called map function, right? It's a Python function. You know, it's not a method. It's a function, okay. And I am mapping this function with respect to this list. Boom! It worked out the output, and I am making it as a list, okay. If it is not a list, it will just simply say it's a function waiting, okay. So by making that list, I can print it and so on. So the mapped lambda list is this, and then I call that one, I get this answer. And you can see this one is square here 16, 7 square is 49. Now I kind of explained whatever I did that I explained here in this in these steps here. You can check it out. So we have come to the end of the list comprehensions. I will call it as function evaluations inside a list. That's, even though it's a long word, long sentence, long phrase, it's more explicit. I'm list comprehension, I don't know, it doesn't really explain well, okay. So I will say function calculations inside a list, and what are the outputs that are coming? They will be coming out as a list output for us. That's called list comprehensions. In the next section, I'm going to talk to you about tuples. Okay, it turned out to be a long presentation. Just give me a moment. I will reduce these kind of presentations later, because I reviewed quite a bit, of the yesterday's. It turned out to be a long one. Thank you very much, everybody.